I made a machine learning project. And this video is like a way to publish my results because I find them really interesting and novel, because I can't really publish anything in like a proper journal. I could if I really pushed for it. Two of my thesis reviewers told me that this is a publication material, but I have no idea how big of a compliment that is. I'm kind of clueless. I just do stuff. So what is the project about? It's a machine learning project that in its core has data efficiency. So you can say that it's a machine learning project that's actually about learning of machines. Like I was studying how do machines learn. I was training an object detection model and I was implementing an active learning algorithm, the whole active learning is about budget of labeling images for training, right? To train a neural network, to train the model to detect and classify some objects, you need images, you need examples of these objects. And sometimes labeling is costly. You can label just everything you have. You have to spend the labeling budget wisely. That's what active learning deals with. You want to find out which images are the most optimal to label because they will teach the model the most. So I was implementing this algorithm, but the problem I set myself was not what data to label. I had already a labeled data set. I was kind of using this algorithm to find out which images should we pick for the model so it performs the best. So I was training object detection neural network models on exactly the same data. The only difference was my algorithm that was picking the order of these images. And the results, actually impressive. I'm actually satisfied with the project because, especially because there is no tutorials on this. Like you can actually search up active learning algorithm implementation tutorial something. You will not find this. You have only the overview of what it is, and the field is just new. That's what's fascinating here. That's what I'm proud of. It took me a lot of time. Don't think that it was like a weekend project. No, I spent a lot of time on this, but ultimately, I didn't fully understand or know what I'm doing, but the plan for this video is that you're free to skip to different parts because I plan on making a technical background and the description of the project itself. So I made it nice for you can see the chapters on the timeline. But I will start the video with giving you the background of how I even got to work on these things because this whole story is such a mess. I have the talent of ending up in really weird situations, but I believe some of you will find this interesting. So I will start with this and then get to the rest. It's like a complete overview of what is the project and how it came to be. So let's get to the story. Oh, that's good. That's really good. So let's go chronologically. It was like May last year, 2023. It was like a second half of 6th semester of 7th semester degree because the last 7th semester is all about the project that you're gonna do, the last one final project. So we were picking these supervisors, and with your supervisor you also pick the topic of the thesis. And what you would normally do is you would pick a topic that you have already experience in, or you feel confident in, or you found like a good resource, good tutorial to follow. Some people even pick a project that they already made. That's what you would do if you're normal and reasonable. But me, do I look normal? I thought to myself, if I pick the project that I already know how to do, that would be easy. And you know what we think about easy lives.
And unfortunately, resilience matters in success. I don't know how to teach it to you except for I hope suffering happens to you. You want greatness out of them. And greatness is not intelligence, as you know. Greatness comes from character, and character isn't formed out of smart people. It's formed out of people who suffered. I don't know how to do it, but for all of you, I wish upon you, ample doses of pain and suffering.
If you have no problems, come up with something. Okay, I'm not that crazy, even though it's kind of true. It has a lot of truth in it, but I'm not that crazy. But I thought to myself, even for an easy project, I would spend a lot of time on this. And back then, by a lot of time, I meant like 2 weeks or 3 weeks. I ultimately spent 3 months of almost everyday work on the project, but that's kind of a spoiler. I was like, I will spend time on this regardless, even for an easy project, because I want to do it well and you have to write like 30 pages of the document. So I wanted to pick a project that would force me to learn something that I already care about learning. And so I picked machine learning with no previous experience, no classes, no knowledge. Just like that. Now, I do not recommend what I did. As I was doing it, I was not recommending what I was doing. That was this level of stupidity. But I did it. It was early June back then. I emailed a professor from my department at university that was teaching a machine learning course. I just emailed him that I have no previous experience, no background in machine learning, but I want to do like a semi-ambitious project from machine learning, and is there any chance we can work together? And he sent me something, like, it was really nice. He sent me something about, like, a paper about compression of tensors. I was like, yeah, that's kind of cool. I don't know what a tensor is, and compression, and like, it was really low level, hard math stuff. I was like, a bit too hard for me. I need something more abstract so I can like learn without diving into too much detail. So I was looking further. I asked him for more recommendations, and ultimately I messaged like 7 or 8 other guys. It was like a recursion of recommendations because I had no idea what I'm doing. I don't know who I'm talking with. I just like, hey, I want to do a machine learning project. Can you suggest me something? And there was, for example, some guy with like that was implementing machine learning algorithms in video games, and I had previous experience with video games, so that sounded cool. But he didn't respond to me. Like, pretty much nobody responded to me except one guy. This one guy. And, you know, people pick supervisors for their thesis based on recommendations from other students, because you want to have a supervisor that's like proven to be useful and helpful and nice to you, that isn't too harsh or rude or something. And I picked this stranger, a complete gamble. Like, you want to work together? Come with me. But I agreed to work with him because the project he proposed had very few good signs. First of all, I was supposed to analyze a scientific publication, which I haven't done in the past, so I wanted to spend time on reading a publication, which was nice. Then the project had open source code, so I could just look inside, analyze their code, learn something new, which was like one of the main factors for picking this project, because that's what I wanted. And also the project was in PyTorch, because some projects are made with TensorFlow, and I didn't want TensorFlow. George had said that TensorFlow sucks. I didn't want to spend any time learning TensorFlow. So I had these all green flags, I picked it. And then the summer break comes. 3 free months for learning. The plan was to have the foundation, learn stuff, do some courses, so I will be ready to start the project during the semester. You know, some people started their projects during the summer break, so they have more time and they have prepared and know what to expect and something. I was like, no, I'm not starting the project. I want to have solid foundation. And I'll tell you right away that I didn't fully succeed. Like, the stuff I learned for 3 months, it was not a lot because I had other stuff going on. Unfortunately, if you saw my video on starting my AI journey, or however I called it, but it was like late August when I started actually learning a lot of AI. So by the end of the summer break, I was not like super satisfied with how much I learned, but I ultimately did like 8 courses, but I did not fully go through them. I was just like, I did the course and I didn't fully grasp the concepts. So I start another course and I get more things, then another one, until it finally clicked. And I understood a lot of things, but still I didn't deal with image classification or object detection. So I had some knowledge, but I was not ready for what was coming. And so the semester begins, October 2023. Before I even started working on anything, I had to make a presentation showing my plan for the thesis, because like we had to make a ton of progress presentations, because why not? And this is the schedule, the plan I showed during the presentation. It did not work, guys, it did not work. The actual plan was to run the code, the provided code with the publication, and the initial plan was to modify their algorithm, understand how it works, modify it, improve it or something. It did not happen. It was like almost everyday work, like 2 hours a day for a month. It was easily over 40 hours of trying to run their project. I'm not speaking of analyzing the algorithm, learning how it works, learning the library that it was implemented in. Nothing, like no knowledge. I was just wasting time trying to run the project. When I was working on it, it was 1 year old, but somehow everything was wrong. The script that was preparing the data set, it was like a preparatory script before you run the actual algorithm, had syntax errors. Like, how is that even possible? How is that even possible? I fixed the errors, I ran the script, okay, but then I'm trying to run the algorithm. And I never did. I put a ton of debugging statements. Nothing worked. I could not understand what's happening. Like, the whole project is just like a zillion of files. Like, you will not understand what works with what. How they even obtain distance matrix. Distance matrix was used to, like, a metric of how similar certain images are to each other. And I could not find how do they calculate it. They just import it from a file. How do they get the file from? Like, did it came with a data set? How did they calculate it? I could not find the code for it. And I had problems with dependencies. These libraries were not working. I was installing old versions of these libraries, but it was still not working. I mean, the authors didn't even provide what library versions were they using. So pretty much the most of this wasted time was spent by just blindly experimenting with libraries and dependencies. Just install this Python with this PyTorch, with this QDAO, with this CUDNN, with these libraries. Then you read on the internet that you need to have all the setup tools because setup tools something, and you're like, you're in this complete mess. And I never got it working. Never, ever, impossible. The summary of this whole thing, as a last resort, I emailed the main author of the paper. That was the owner of the GitHub repo, and that's the email if you want to read it. But he did not respond for like half a year now. So I had to scrap the idea. I had to come up with something. And my main problem with their project was the foundation library. They were using detection library, and I didn't like their documentation. I just didn't like what was happening. Oh, I forgot that after their project didn't work, I tried to make a new clean project with all the newest library versions, and just kind of like I would be having their code as a reference so I can build my project from scratch. But even the demo code of detection was not working for me. On clean everything, it had to work. I think one demo worked, the other didn't, or something like this. I was just so unhappy with the library. I was looking for alternatives, and I found the biggest competitor of detection was the Tektron 2 by Meta. I installed it just to try it out, and it just worked. It just worked. Wow. I mean, how down bad do I have to be to see something that works, that should work, and I start clapping? I was so happy. What does that mean? What does all this mean? First of all, we're starting over. Second of all, I cannot have reference code. The code, we have to regard all the code because the foundations, the frameworks, everything is different. We're absolutely nowhere after a month, but at least I had a library that just works. That means that instead of spending my time to make it work and struggle and make no progress, no learning, nothing, I could spend the time on actually implementing the code, learning the library, and do something productive. And that was the very end of October. We can say that just November. On November, I could start working on the project. And to clarify some things, because when I tell this story to various people, they often ask me about my supervisor. And yes, supervisors often help you a lot, where they tell them a lot of stuff, provided with learning resources or something. That was not the case for me. And I cannot fully answer why, because I have no idea. But look at it this way. First of all, I approached a stranger, a random guy, that I want to do something ambitious and that I will spend a lot of time on this regardless, because I want to actually learn this. So maybe he wanted to give me more freedom, or like, you know, just see what I'm capable of. Or maybe that was his style, that he gives me a lot of freedom and responsibility, and he's there as like a backup but lets me deal with my problems. Or something, you know, I cannot be super sure. It's not like I even asked him for help. I'm saying that in your case, if you ask for help, if you don't feel certain in what you do, you will most likely get help. In my case, it was fine. I emailed my supervisor once that it's super tough, that it's not working, I have to scrap the whole project. He was like, just keep going, I understand it's hard, just don't give up. And I appreciate that he was not intervening a lot. I could show off my skills. He told me that if we'll have to, we'll change the goals of the thesis, do not worry about it, because he understood that, you know, the initial plan could not be fulfilled. And I made it. I made the project. I wrote everything from scratch in this new library. I was not looking at their code because I couldn't. It wasn't any useful. I was looking at the publication and math equations included there and descriptions. Not everything was described, so I had to fill a few gaps. But other than that, I actually made it. I had some problems in the meantime, of course, with reproducibility and speed of training, because the initial training round was like 17 hours and I had to speed it up. I had to implement multi-threading for calculating the distance matrix. That also took me a lot of time, but I didn't know what I was doing. Now when I think about it, after I implemented everything, I thought to myself, wait, cannot I calculate the matrix on a GPU? And if there was an easy way to actually do it, that would be embarrassing. But you know, the whole code is actually a mess. You'll see later. I will definitely link the document somewhere so you can read in greater detail about the problems along the way and the background. But that's mostly it. The deadline was 22nd of December, so it was roughly a 2-month long project along with writing the document. But I was sitting on it actually every day. It was like all my life, all I talked about. I sat on it every day. I was leaving the models training for the night. I was waking up in the morning, checking the results, if everything's fine. It was not fine and I had to redo everything. All these calculations, many models tested, multiple times to average up the results. But I made it. So now we get to part 2, to an actual description of the project. Let's begin. This is the paper, the famous paper, engineering thesis. This is the title page that was provided to us, so I couldn't change it. And engineering thesis titled Application of Active Learning and Self-Labeling in Pattern Classification. But my supervisor came up with the title before I started work on this, and goals changed in the meantime, so I think the title is vague on purpose. If I could come up with the title now, after I made the project, it will be something like Exploring Active Learning Methods that Maximize Sample Efficiency. Something like this. This title would be much more aligned with the contents, but whatever. Let's go below. Abstract. Okay, I'll read the whole abstract. This research builds upon the foundation laid out by the paper Plug and Play Active Learning for Object Detection that introduced active learning pipeline utilizing uncertainty-based sampling and diversity-based sampling for object detection neural network models. My work implements the whole active learning algorithm in Detectron2 library from scratch, and it aims at deepening the understanding of why this method is so effective, and at answering questions such as how do uncertainty-based sampling and diversity-based sampling individually contribute to the training process, which of these methods should be given priority in different contexts, and will diversity in machine learning have similar characteristics to interleaved studying method used in education. That's like a teaser, so you know what to expect. Then we have table of contents, of course, implementation, theoretical introduction, experiments, conclusions, whatever, doesn't really matter for now. What matters is functional overview. This tells you what I actually made. so you know whether to keep reading, whether you're interested in what I actually made. So this project implements an active learning algorithm, of course, from the paper. I built the project in Detection 2 while they base their project on ML detection. Okay, it can train any object detection model based on any backbone network that are both supported and maintained in Detection 2 library. And you can see that in their model zoo, so you know which models do they support. Like we have faster RCNN with Resident 50, Resident 101, RetinaNet, and other stuff pre-trained on different data. For now, I support any dataset with annotations in YOLO format. Each model training round consists of initial training round and then a specified number of active learning rounds, for which the percentage factor of images picked by uncertainty has to be specified. That enables the user to experiment and compare final performances of models that were trained on the same dataset but with different sampling methods. All round training images picked by uncertainty sampler, all picked by diversity, or half-half between these two methods, or any combination in between. Aim of this research. You can read the details yourself, of course, but what's important is that I wanted to investigate what made their algorithm so effective, which we'll get to in a second, because that's interleaved. We'll get to this, that's really interesting, but that's important for conclusions, because I was comparing diversity sampling to interleaved training used in education. But okay, that's later. Oh, that's interesting as well. Okay, anyway, theoretical introduction, efficiency of data usage, Jan LeCun tweets that tell you how important it is to progress data efficiency in neural networks. You can read all that, that's a good part. Then active learning, the whole background of what it is and what I'm doing. So I told you already at the beginning, I don't know why I made this graphic, it's not really that much useful, but it consists mainly of 4 parts. So we train the model, make inference of it to get outputs, then query, run the algorithm, process these outputs however you want to, then label them and train. That's like a whole active learning round. And what are the outputs? On an image, you have a bounding box, a class of this box, what object it is, and then the certainty, the score of how confident the model is. And so you have different algorithms that process these outputs to pick next images for training. And we have 2 main sampling methods with different details, but like 2 main groups. And first main group of these sampling methods is uncertainty-based sampling, which prioritizes uncertain images, where the model is like not confident in their predictions. And we can visualize the decision-making process like this. This is label A region, this is label B, and this line kind of represents objects that are 50-50, that the model is uncertain to which label they belong. So maybe when we use uncertainty-based sampling, we will label mostly, just use for training mostly these images to make the model more confident, to push these points kind of like outward to, so it's not 50-50, it's more like 90% that this is label A. But this sampling has its problems because we don't prioritize being correct, we just prioritize being certain, right? If our model mislabels something, then we think it's okay because he's certain, he's wrong. Then the next group, the main group, is diversity-based sampling, and without getting into much detail, it just prioritizes diverse samples that are dissimilar from each other, not necessarily uncertain, not because uncertainty means kind of hard for the model. So this sampling doesn't prioritize hard labels, hard images, it just prioritizes diverse images. And this is the pipeline, the algorithm from the paper that I was analyzing that achieved state-of-the-art by combining these 2 methods in a series. And here I describe this algorithm. And this is not necessary, but maybe it helps someone. That's how the pipeline works. We have a total image pool here. Then we sample uncertain images, hard samples, and from these hard samples we sample diverse ones, and then we pick that for training. That's how the algorithm works, and that's visualized also here. And they train on percent of images round by round up to a certain point. And you can see that throughout all these rounds, it was better than the competition at least. And then we get to my work and failure of initial plan. Here I describe the problems I mentioned to you about with running the original project. But for example, look here, arguments n-labeled. In original code, the n-labeled is casted to an int, and then they added with strings without casting at first. Like, what even happened here? More problems, and different plan. After many setbacks, I managed to build the whole project using detection tool. Okay, implementation, that's not important as well for now. We have basic functions, something, how I implemented the sampling methods, my equations, entropy, ooh. So we can proofread the equations, maybe they make sense to you, maybe they don't, I'm not entirely sure. Cosine similarity, CCMS, which is like their version of diversity sampling that I try to faithfully implement. And this matrix, spinning at the compute. Oh, that was interesting. Not too important, but wait, do I show it? Oh no, I don't show it. Oh, imagine being happy that you implemented the algorithm after so many setbacks, and then one training run lasts 244 days. That was funny. Ensuring reproducibility. This was my initial result of different models, comparison of their performances, and look at round 0. Round 0 was not even active learning round. That was initial training on exactly the same images for every model. I was like, oh, what is this variety? So I had to explore it, fix it, something, and that's the ultimate result. It's not fully deterministic, but it's pretty close. I was satisfied with it. Final pipeline. So this is the description of my part, of my contribution to the whole project, because you remember their pipeline. Where is it? Here, they used uncertainty-based sampling, then diversity-based sampling, okay? I looked into their source code, and how they combine these methods is that, first of all, they had a very huge pool of images, and they had a target number of images. And 4 times the amount was picked by uncertainty. And then this pool is filtered down to a target image count by diversity sampler. But how I did it, how I implemented the pipeline, was like this. Like, we have a total pool of images, we have our target number of images, and the difference between these two counts is how many images should you filter out with samplers. So I have this coefficient that specifies percentage of images filtered out by uncertainty. You can see it being visualized here. So when the coefficient is 0, meaning 0% of images will be filtered out by uncertainty. That means that after the uncertainty sampling, we have exactly all the pool available still. Like, uncertainty sampling did nothing. And on the opposite side, we have the coefficient equal to 1, meaning that all this count of images will be filtered out by uncertainty sampler, meaning that diversity sampler will have nothing to do. Like, you know, here's 100 of images, and from these 100 of images, give us 100 most diverse ones. It's like, oh, okay, thanks, man. So that's the pipeline. I hope it's somewhat understandable. And then we run the experiments. Here I was testing what is the optimal iteration count to train for. And I picked this spot as like a decent place, 3000 iterations. And here I run the experiments. 3000 iterations, 4 rounds, plus 1 initial round, so 5 in total. Random seed, output, and the UD split values. Technically, the last one doesn't matter, you only need 3 because there's no images left later on. But I provided 4th just to be safe, And yeah, then we get the results. Oh, I could say a lot here. Okay, first of all, look at these. These are the main coefficients. This is only uncertainty, only diversity. And I try to group them to kind of have more diversity-oriented models to the right and more uncertainty focused to the left. And you can see, what can you see actually? What can you see? And first of all, look at diversity-oriented models that are to the right. They seem to fall behind. at the beginning. The most diversity-oriented model with no uncertainty sampling seems to really fall behind after round 2. But ultimately, that makes me so happy. Ultimately, it performed the best. And we can really see that diversity-oriented models performed the best on average. Even though after round 3, full-on uncertainty model performed the best. And these scores are average scores of 2 separate runs on different seeds. And you can see all the numerical results in an appendix A. So we have different metrics on 2 separate seeds, and you can analyze the data yourself that the patterns are the same. So coming back to these results, we can say more things. That's just interesting for now. We'll get to conclusions, to the final conclusions in a second. Here I also provided you with different metrics, like a score for objects of different sizes. So for large objects, it's roughly equal. For medium objects, these models win. For small objects, these ones. But I don't believe it tells us a lot. Like, it can be just specifics of the data set, because medium objects were most common, and for small objects, something else. I'm just not sure. It would have to be tested on different data sets. Peer-reviewed, so to speak. Science. This is science. But then we get to conclusions, to the main conclusions, and I'm gonna read it. I'm just gonna read it. My research fulfilled its purpose, of course. There are quite a few patterns that seem to be universally true, even in wider context than merely training object detection model. First, diversity sampling is a key for all active learning methods. It enables the model to explore more solutions and gravitate more towards a global optimum, even if it takes more time. Generally, in the long term, diversity beats competing active learning methods. Second, uncertainty sampling might be thought of as a greedy algorithm prioritizing getting the task done over finding global optimum. It performs well in the short term, which can cause it to overfit the data quicker. 3. Uncertainty-based methods are not needed for effective active learning and might be completely omitted in specific scenarios. No uncertainty sampling performed the best, right? Their usefulness comes mostly from how easy it is to compute uncertainty, especially compared to diversity. Because for diversity, you have to compute the thesis matrix of like how similar each image is to each image. Like, yeah, it takes time. Which can be used to propose candidate pool of challenging samples for diversity sampling, making the whole system diversity oriented but also compute efficient. That's how I understood the whole pipeline, the whole algorithm, the combination of these two sampling methods. Like, it's all about diversity, but uncertainty-based sampling helps you to filter down the candidate pool. And then 4, diversity-oriented machine learning is an equivalent of interleaved learning in education, where the agents underperform at the beginning and they are not certain of their abilities, but the strategy beats competitors in the long term in all kinds of tests. Then we come back to the whole background that I skipped in the beginning, that somehow after I made the whole project, I kind of remind myself of interleaved studying in education. In school, we exclusively use the block method. Like, we go topic 1, then topic 2, topic 3. An interleaved method of studying is just interleaving these topics, so you don't know what to expect next. And I read studies on it that interleaved training is known to be better, known to perform best in the long term. And here are the confidence scores that learners think that blocked training helped them the most, but ultimately they performed much better in the topics they used interleaved studying for. And here's exactly what we observed in our results. I mean, blocked training is not a good analogy for uncertainty learning, but still, this is just not diversity, and this is diversity. And diversity underperforms at the beginning, but wins in the long term. Isn't this just like, when I saw this, I was just excited. Where is it? Underperforms at the beginning, but then it wins. However, it is worth keeping in mind that my tests were only performed on a single dataset with around 6,000 images with 2 different random set seeds. My research is a pointer of what might be interesting to explore to advance artificial intelligence in the direction of data efficiency. I would be glad if more people got invested in the topic and confirmed, refined, denied my claims. Below that, you can also see detailed conclusions where I comment on each of these points, but that's for you if you want to read more of it. Bibliography, of course, numerical results, and this is the mail that I mentioned in this video, I think. And yeah, that's the whole thing. That's kind of like all there is to it. That's the whole project, what it's all about, the conclusions, the significance and everything. But I think what's left is that I show you the code. Oh, I'm not happy, but I'll do it. Okay, we'll go to the code super quickly because I realized that I might update this, then this video would be outdated. So everything is in the description. I'll have to upload the code to GitHub. I will have to start using it. So everything there will be up to date and properly described with all the details, maybe like what every file does. But just to show you, get you a feel of how this currently looks, because I should clean the code, so the details will change. I should clean the code. I don't want to. Maybe I will, maybe I won't. But just to give you a feel of what different files are all about, we'll go through them. We have this folder, so we have a few files of interest. First of all, I tried to make everything modular, so I made a config file with all hyperparameters and even folder names. But I don't know if that's clean. Like, I just experimented with this code. I mean, it's not that clearly written. I don't know if that's useful, but that's for example a folder name of round work data, and the name is all round, active learning round. Does that work? Does that make sense? These are all the parameters you can give, but this whole file is like a main script that you run to initialize training. So this is like clear of what's happening, of what functions are called. But utils is like a whole file of like a whole backend kind of. I don't know if that's a proper way to use the word, but these are all just functions that are used in the main script to keep the main script clean, right? So it's like more visible what's happening. Then experiment is a bash script which I used actually for training. So these are all different names of the models, different UD splits, different output files, but this is like an example usage of the whole thing. And then evaluate, you can see it being called without any parameters. So this is a script for evaluation to get the score of how well the model is performing. And this is kind of a primitive script. I just manually input all the model names. So I just go through them, test them, and then save the outputs to CSV file that will look like this. Just a bunch of data for further processing. And it's important to remember that you go through modules that are in this folder, in these output folders that you provided here. So this is output foo an. So I would have to delete the 3 and then output dash foo an. That's how you can get to the folder, to this folder, and get model weights. So let's evaluate. Could use some work, obviously. And plot loss, I think that's someone else's file that I barely even used, but that's how I got all these plots from that were used only for testing. So it's not an important file, but it's there. And by the way, this is how the folder looks like with all these outputs, different routes, different models, metrics. Here are console outputs for all these trainings, initialization, distance matrix. You get it. This is training. That's it. And I believe that's everything. If I didn't say anything, it will be on GitHub. I think. I'll try, okay? I'll try. And honestly, I just want to move on from the project. I barely knew anything when I was working on it. Like right now I'm working on reinforcement learning, but maybe I'll come back to object detection and implement the whole training process without detection too. I don't know, I just kind of want to like do new stuff. So I'm happy to move on. That's the project. Check out all the links, all the files, all the documents, and thanks for watching.